Molten zinc chloride is an electrolyte. Which row shows the products formed at the anode and the cathode when molten zinc chloride is electrolyzed? So remember, zinc will be the metal and chlorine will be the non-metal. Zinc will form positively charged ions. Metals always form positively charged ions, and chlorine will form negatively charged ions. So charged ions, positively charged ions, or cations will be attracted towards the negative electrode, the cathode. Remember, catty attitude, cathode negative. And the positively charged anode will attract negative anions, so the non-metal ions will always be attracted to the anode. So produced at the anode, we're looking for the non-metal, so it's going to be one of these two. Chlorine is the relevant one. We know oxygen isn't an issue here because it's melted zinc chloride. It's not in solution. There's nothing else there. There's only zinc and chlorine to separate. So it's going to be one of these two. And zinc is produced at the cathode. We know it can't be hydrogen because it's not in solution. It's just melted. So it has to be this one. Which of the following is the reason why molten zinc chloride is an electrolyte? So molten means melted. So an electrolyte is something which contains charged particles and can conduct an electric current. So obviously an ionic lattice contains ions. So it contains molecules that can move. No. It has a giant structure. That's true, but not relevant to why it's an electrolyte. Diamond has a giant structure. It contains delocalized electrons. No. There's no free moving electrons here. It's just charged particles. It contains ions that can move. Yeah, so this is in a solid state where they're not moving, but when you melt them, they separate out and they can move. So this is the answer. Copper sulfate solution was electrolyzed using copper electrodes. Draw a label diagram to show the apparatus that is used to carry out this electrolysis in the laboratory. So we're using copper electrodes and we've got copper sulfate as a solution. I'll just show you what I've drawn. So this would be the kind of thing you want to draw. You want to show that anode electrode, which is copper, cathode electrode, which is copper. Positive terminal would be the anode, negative terminal would be the cathode. Remember, negative catty attitude. And copper sulfate would be the electrolyte. So you put that in your beaker here. Pretty simple. Before the electrolysis, the masses of the electrodes were determined. After the electrolysis, the electrodes are washed and dried and their masses redetermined. Figure 6 shows these masses and the resulting changes in the masses of these electrodes. So you can see mass before, mass afterwards. They have a slightly different mass before anyway. They don't all start off the same mass, but we can see the cathode one has gained what the anode has lost. So there's been a transfer of mass from the anode to the cathode, from the positive to the negative. Explain why. Firstly, remember the rhyme oil rig, or the word oil rig, because you need to know that oxidation and reduction is happening here. Now, oxidation and reduction can refer to oxygen, gaining and losing oxygen, but in electrolysis and ions, it's talking about electron transfer. So remember, oxidation occurs when you lose electrons. Oxidation is loss, and reduction happens when you gain electrons. So reduction is gain. Now, the other thing you need to know is why this is the positive terminal and this is negative. This is negative because electrons are flowing down this way and constantly accumulating here, and electrons are being removed from this part, so that it's relatively more positive because you're removing negative particles, and because they're building up here, this is relatively more negative. So that's why this is the positive electrode and this is the negative one. Now, the other thing is copper forms a 2+. So a copper atom versus a copper ion. A copper ion has a 2+ charge because it would have lost, the copper atom would have lost 2 electrons. So let's have a look at what's going on. So remember that this is the anode over here. This is the positively charged electrode, which basically takes electrons away. In fact, just to make this clearer, I'm going to draw that here. So this is positive and this one over here is negative. All right, let's look a bit closer. Okay, so we start off with a copper atom. So a copper atom, which makes up the copper electrode, basically will transfer 2 electrons because of the electric current. 2 electrons will be pulled away and they'll move around the circuit because remember, copper has 2 electrons on its outer shell. So the copper atom is oxidized. Oxidation is loss. It's lost 2 electrons. When it does that, it becomes an ion, and as an ion, it doesn't stay attached to the electrode. It basically enters the solution. So now you've got copper ions dissolved in solution. Now, because they're charged, they'll be attracted to the opposite charged electrode, positive to negative. So they're attracted to the cathode. So they move towards the cathode, and then at the cathode, what happens is, where electrons are supplied, basically 2 electrons are supplied to this copper ion, and it becomes a copper atom, and so the copper ion is reduced. The atom was oxidized, but the ion is reduced because reduction is gain. You're gaining back 2 electrons. So it's quite simply, parts of this electrode are forming ions because they're losing electrons. They're entering the solution. Then the ions are bonding with this electrode and gaining 2 electrons to become atoms again. So atoms are being transferred by this process, which is why the mass is reducing here and increasing here. You can summarize this using the half equation. So at the anode, what's happening is you have a copper atom and it's producing a copper ion and 2 electrons which whiz around the circuit. But at the cathode, you're basically having a copper ion and 2 electrons combining to produce a copper atom. Remember, the arrow is a production arrow. This is what comes after the arrow is what's produced. So we're starting off with a copper atom at the anode, but we're producing a copper ion and 2 electrons. But at the cathode, we're starting off with a copper ion and 2 electrons, and we're producing a copper atom. That's why the arrow is in a different position. So how do you write this? Copper ions move into solution at the anode, or the anode lost copper for 1 mark, and copper ions move out of solution at cathode, and cathode gained copper. So 1 mark rather for saying both, linking these points. So what's lost here is gained here. Just by saying that, what's in brackets here, you get a mark. Next, at anode, copper atoms become copper ions. So you could say copper atoms are oxidized for a mark at the anode. And what that means is they're losing 2 electrons. At cathode, copper ions gain 2 electrons to form copper atoms. So you can say the ions are reduced. You can also, if you're feeling a bit more sophisticated and you don't feel like writing much, if you write these half equations, you can actually get full marks, providing you make the point that anodes lost a copper and cathode gained copper. But just by writing this, it'll save you all this writing. So half equations can save you a bit of time. Right. When sodium sulfate solution is electrolyzed using inert electrodes, hydrogen is formed at the cathode. Write the half equation for the formation of hydrogen gas from hydrogen ions, H+. Well, firstly, you need to know that hydrogen is always a diatomic molecule as a gas. That means it's a molecule that contains 2 atoms. All gases in the periodic table, all elements which form gases, are diatomic: nitrogen, oxygen, hydrogen, chlorine, fluorine. The only exception are the group 0 stable gases, the inert gases or the noble gases, because they don't react. So when sodium sulfate is electrolyzed using inert electrodes, hydrogen is formed. We just need to get the half equation. So what's happening? Well, to make H2, what we've got starting off with hydrogen ions. Now, obviously, if we're making H2, we need 2 hydrogen atoms to start off with. Now, what happens really is an ion of hydrogen is just when an atom of hydrogen has lost that outer electron. So and it's become positively charged because there's more protons and electrons. So if you want to get an atom of hydrogen, you need to gain back that electron. So what's happening is you have hydrogen ions, 2 hydrogen ions, gaining individually an electron each, 2 in total, to become 2 hydrogen atoms, and then those atoms are covalently bonding to form H2. But how do we write that? Well, we're saying 2H+, so we're starting off with 2 hydrogen ions, plus 2 electrons, because they gain 2 electrons, form H2. That's it. Make sure you understand that you must have charges where you're showing the ions, but the atoms or the molecules won't have charges because the electrons have combined to neutralize or discharge the ions.